Here's what we know and don't know about black holes. First off, black holes aren't really holes, they're just incredibly heavy objects made out of matter just like you and me. The difference is that all that matter has been squished together into an area smaller than our solar system. The matter inside a black hole is divided into two parts. The outer part is known as the accretion disk. It's full of gas, dust, and plasma particles all flying around at high speeds and emitting light. The inner part is known as the singularity. That's where all the matter in the black hole gets crunched down to an infinitely small point. The problem is that no light can get out of a black hole because it's pulled back by its gravity. In fact, nothing can escape a black hole. Once something passes the event horizon, which is the boundary around the black hole, it cannot come back out, not even light. And since nothing can come back out, we can never actually see what happens inside a black hole. All we can do is look at the accretion disk, which is the ring of material around the black hole. That's why black holes are such great cosmic detectives. They let us see things we would never see otherwise. So now that we know what a black hole is, let's talk about what we know about them and what we don't. What we don't know. How does time work near a black hole? We think time slows down near black holes, but we don't really know for sure. To understand this, let's take a step back from black holes for a moment and consider something much more familiar, a clock. You probably think of a clock as having a tick-tock, a pendulum swinging back and forth or gears turning. But really, a clock is just counting the vibrations of a tiny little crystal inside. When the crystal vibrates, electrons inside it move from one place to another. Electrons have wave properties, and when they move, they create ripples in space-time. Those ripples travel outwards at the speed of light, just like the ripples of a stone dropped into a pond. If you wanted to measure the passage of time near a black hole, you'd have to count those ripples, but here's the problem. The closer you got to the black hole, the slower those ripples would seem to move. So the closer you got to the black hole, the slower your clock would run. Now imagine getting closer and closer to the black hole until you reached the event horizon. At that point, the ripples would seem to stop altogether. That's because nothing can escape a black hole, not even light. So if you were counting those ripples to measure time, you'd eventually reach a point where it seemed like time had stopped completely. But that doesn't mean time actually stops. It just means that nothing can escape the black hole to tell us that time has passed. In other words, we can never actually know what happens inside a black hole. All we can do is observe the effects it has on the universe around it. What we do know. What stuff looks like inside a black hole. Because nothing can escape a black hole, we can never directly observe what matter looks like inside their event horizons. But we can make some educated guesses based on what we see around black holes. For example, we know that matter gets really hot as it approaches a black hole. That's because the matter is being pulled apart by the black hole's gravity. As it gets closer and closer to the event horizon, the gravity gets stronger and stronger. Eventually, the gravity is strong enough to overcome the electromagnetic force that holds atoms together. When that happens, the matter is no longer held together in a solid form and it starts to glow. The glow is emitted at all wavelengths of light, but it's especially bright in the X-ray part of the spectrum. That's because X-rays are emitted by matter that's moving really fast. Since the matter near a black hole is being pulled towards it at nearly the speed of light, it emits a lot of X-rays. So if we want to learn more about what's happening near a black hole, we just need to look for X-ray emissions. Of course, looking for X-ray emissions doesn't tell us anything about what's going on inside the event horizon, but it does tell us about what's happening just outside the event horizon. And that's still pretty cool. How big is a black hole? You may think of black holes as giant cosmic vacuum cleaners that gobble up everything around them. But that's not really true. The truth is that black holes don't suck anything in. They're not even aware that anything is around them. That's because a black hole's gravity is no different than the gravity of any other object of the same mass. Only when an object gets close enough to a black hole does its gravity start to become noticeable. That's why if you were far enough away from a black hole, you wouldn't feel any different than if you were near a star or planet. Of course, as you got closer and closer to the black hole, its gravity would start to become stronger and stronger. But that's no different than what happens on Earth when you get closer and closer to a planet. The only difference is that a black hole's gravity doesn't weaken with distance like a star's gravity does. That's because a black hole's gravity depends on its mass, not its size. The bigger the black hole, the stronger its gravity. So while a black hole's gravity can be strong enough to pull in stars and planets, it's not strong enough to pull in light. Can we travel through a wormhole? Wormholes are tunnels through space-time that connect two different points in the universe. They're kind of like shortcuts through space. Unfortunately, we don't know if wormholes actually exist. Some physicists think they might, but we've never seen one. There are a few reasons why wormholes are unlikely to ever be found. First off, they're very rare. We think that for every meter of length, there's only about one wormhole within 10 to the power of 39 meters. Second, wormholes are unstable, they collapse and reform all the time, so you'd have to get lucky if you wanted to find one. Finally, wormholes are dangerous. The matter inside them is moving really fast and could easily destroy a spacecraft. Despite all those dangers though, some intrepid explorers might be willing to risk it all to find a wormhole. It could be the ultimate adventure. Just make sure you bring a good guide with you. A good guide will know how to avoid the dangers of a wormhole and help you navigate through space-time. Are black holes cosmic vacuum cleaners? This is a question that comes up a lot. Are black holes cosmic vacuum cleaners that just swallow up everything around them? The answer is no. Black holes aren't vacuum cleaners. They're just normal objects that happen to be very dense. The reason why black holes seem like vacuum cleaners is because they're very massive. The more massive an object is, the stronger its gravity is. Gravity pulls everything towards the center of an object. So if an object is massive enough, it can pull in anything that gets too close to it, including light. Eventually, the gravity is strong enough to overcome the electromagnetic force that holds atoms together. When that happens, the matter is no longer held together in a solid form and it starts to glow. The glow is emitted at all wavelengths of light, but it's especially bright in the X-ray part of the spectrum. That's because X-rays are emitted by matter that's moving really fast. Since the matter near a black hole is being pulled towards it at nearly the speed of light, it emits a lot of X-rays. So if we want to learn more about what's happening near a black hole, we just need to look for X-ray emissions. Of course, looking for X-ray emissions doesn't tell us anything about what's going on inside the event horizon. But it does tell us about what's happening just outside the event horizon. And that's still pretty cool. Do black holes destroy galaxies? The answer to this question is sometimes. It all depends on how big the galaxy is. Black holes come in a range of sizes from a few million to several trillion times the mass of our sun. The larger the black hole, the more destructive it is. If a black hole is small enough, it will just sit in the middle of a galaxy and not cause any major problems. However, if a black hole is large enough, it will start to disrupt the galaxy. It will pull stars and gas towards it and eventually it will consume everything in sight. So the answer to the question, do black holes destroy galaxies, is sometimes. It all depends on how big the galaxy is. Do black holes suck stuff in? No. Black holes don't suck stuff in, they just have a strong gravitational pull. Anything that gets too close to a black hole gets pulled in, whether it wants to or not. It's not like a black hole reaches out with some kind of straw and sucks stuff in. It just has a strong gravitational pull that affects everything around it. That's all we know about black holes. What do you think? Let us know in the comments below. Do you find black holes fascinating or terrifying? Be sure to subscribe for more science videos.